Good afternoon, everyone, and welcome to the second lecture of our online lecture series. This is Juma Ghosh, curator at Nehru Science Centre, Mumbai. We are holding this week-long lecture series where we will help the students to explore various career opportunities in future if they choose to work in the frontiers of science. Today's speaker, Dr. Sejal Shah, will be talking about the future opportunities for the Indian girl students in ITER India project. Let me take this opportunity to introduce her. Dr. Sejal Shah did her Masters and PhD in Physics from the MS University of Baroda and joined in for plasma research as a scientist in 2008. She was then deputed to work for the ITER India project. ITER India is one of the 7 mega science projects in which India is participating along with other 6 domestic agencies for the realization of fusion power as a source of energy for future power plants. Presently, she is working on the effect of radiation on ITER grade insulating material. With these words, I'd like to thank Dr. Shah for accepting our invitation, and I'm handing it over to her.
Thank you very much, Ms. Juma. It's really nice of you. I guess I'm audible, right? Okay. So, very good evening, everybody. And as she has already introduced, I'm Sejal, and on behalf of ITER India, I would like to thank Nehru Science Centre for this wonderful opportunity to interact with students, and it is really nice of holding this kind of seminar to encourage the students, particularly for the field of science and technology. I just share my slides. I have prepared the slide keeping in view that all of you belongs to student category, and those who are already experienced and have much, I mean, if you are knowing much about this project of ITER India, if you have visited mega science events, then please excuse me. This is very basic things which I am going to discuss about. And so let us start. The two things I am keeping it concentration here for the presentation. It's about ITER. I can say a step towards clean and safe energy. Why I'm saying so, we'll look into the upcoming slides, and then future opportunity for the girl students in ITER. So that is forming the outline of the presentation. So I will briefly introduce about ITER, why it is required, what are the key features of the project, and how India is contributing to ITER. And the most important one, that what is the status of women in such kind of project in India and abroad, and further scope. So with that, let us start. This is very basic thing, and I'm sure you all aware about it, that these are all home appliances which makes our life much simpler and smoother. And to operate them, we need electricity. Electricity comes in form of energy. So we need to understand that what is the source of energy. In one of the mega science event, when ITER India was also having exhibition, and one very small kid of grade 1 or 2 possibly visited the stall, and when he was asked that, do you know what is the source of energy, and very innocently he said that we get energy from bone vita. So, well, that's, I mean, he's not absolutely incorrect, but here we are talking about the energy in terms of running appliances, energy in terms of requirement of industry, in terms of communication, transports, everything. So that is different source of energy. And here we can talk about two types of energy sources. So student who are grade 5 and above, I'm sure you must be aware about this name about renewable energy source and non-renewable energy source. So renewable means we get plenty in amount from the nature, like solar energy, wind energy, hydraulic energy, or even nuclear. Now here I'm talking about nuclear fission, energy. So this energy comes with some limitation. They are limited not in amount, but they have limitation of efficiency, because if we see the solar flux which is coming on earth is very less, and out of it how much we can extract is further quite less amount of which we can utilize. Secondly, the installation of such kind of source need enormous amount of space. And then also it also depends on the nature. So sometime if it is cloudy, if it is not, there is no wind, then we have to rely on the other energy sources. When we talk about nuclear, then there is a possibility of radiation hazard, and there are some accidents in the past, like Chernobyl and Fukushima, which happened during a tsunami. So, keeping that in mind, we have to look for alternative energy source which is safe. Now, if we talk about non-renewable energy sources, they are basically mainly coal, oil, and natural gas, which we can extract from Earth's crust. But the limitation with them is they are limited. Secondly, they are taking billions of years to form inside the Earth. Then once we burn either of them, it will produce greenhouse gases and pollute environment. Though despite of this limitation, we have to rely on these kind of sources because we do not have any alternative so far. So if you look at the central image, I am sure you will be able to see my cursor. So right now, we are depending on oil, gas, and coal for our major energy consumption. And if you see the amount of renewable energy sources which we are utilizing are relatively very, very less. That the limitation I have already explained, because the technology also yet not been established to which we can extract maximum amount of energy from that kind of sources. So what is the alternative for that? For that, we are looking for fusion reactor. Now, what is fusion? Fusion means when two very small atoms collide with each other and make a bigger atom or some other byproduct. And during this process, enormous amount of energy gets released. If we extract this energy, run the turbine, and if we can convert it into electricity, then our life becomes very easy. This is exactly the process which is happening in the sun and the stars. So as you are all aware that in sun, since millions of years, hydrogen is burning and it is providing lots and lots of energy. So if we can do similar kind of experiment on the earth and do some kind of fusion which is taking place in sun, then we can also extract similar amount of energy on the earth. So if we look at the positive side of this kind of reactor is that the fuel is easily available. It provides very clean energy because the byproduct is very less. Secondly, there is no possibility of chain reaction in such kind of fusion process. So you cannot expect the accident which has happened in case of fission reactor. And the radiative material, radiation which is coming out of this material can also very less as compared to that kind of source. So here I have shown an image. It is a ITER cross section I've taken from ITER site, and it is just a ray of hope to get or to step towards the safe and clean energy sources. So for ITER, there are 7 different domestic agencies, including India, participating and contributing to make this machine working. Right now, it is in conceptual and during in development stage, the machine is being developed. The site is ready. The construction is taking place, and once the entire machine is assembled, then experiment will start. We'll see how it is progressing in the upcoming video. So because if I say, it won't be that effective if, rather than if you can see the video, it will you can capture the essence of the project. So right now the project is being built at Cadrash, which is the southern part of the France, and India became the seventh partner in 2005. The objective of ITER is fusion gain Q greater than or equal to 10. What does it mean? That whatever input energy you provide, you should get 10 times higher output than the input one. So ITER's mission is to demonstrate the feasibility of fusion power and prove that it can work without significant negative impact. So if we look at the key features of ITER, this is how it looks like. I'm sure if you are looking for the first time, it will be a little difficult for you to understand the components and how it is signed, but with the video, it will be little bit simpler. And those who are already aware with the mega science event and some of the talk, it would be easy for you to understand and realize how complex it is. So if we talk about it, a vacuum vessel, which is inside component, and it is facing the plasma. And if you see the vacuum, its weight, it is about 8,000 ton. So it is even heavier than the Eiffel Tower. Then if we talk about the magnetic field, because they are superconducting magnetic fields, so for superconductor to function, uh, the functioning requirement of superconductor is extremely low temperature. So we have to keep it very low. And for that, it is kept at liquid helium temperature of minus 269 degrees centigrade, which is even colder than the Pluto. And if you see the operating temperature at the core of the vessel, so it is 150 million degrees centigrade, which is 10 times higher than the sun. Why? Because at sun, the fusion can take place because of its own gravitational force and extremely high temperature. But at Earth, we have to replicate similar kind of environment, but because we do not have as strong gravitational force as sun have, so we have to keep that temperature extremely high of about 150 million degrees centigrade. So systems are designed in such a way that it can heat the plasma to that extent, and it can cool the magnet to the extent which is mentioned here. So if you can imagine, this diameter of this machine is about 30 meter, and in this 30 meter, the coldest part on the earth and hottest part of the earth is at the same place. Okay, then if we see some other features, like the machine will be operated remotely, operated and maintained, because it's not feasible to operate it or handle it with man's hand. So remote operation, its planning, its design is done accordingly. Then cryostat is the outer jacket, which you can see, this white one. It is provided by India, and it is the world's largest vacuum vessel with a volume of about 16,000 meter cube. The, the density of air during operation is 1 million less denser than the air. Now, as I said, these are superconducting magnets which are capped for the extremely high magnetic field, which is the requirement of the experiment. And if we see the strength of superconducting magnet, it is about 1 lakh kilometer. So if you start from on the equatorial of the earth and make two round, that is the length of the superconducting strand which are used in ITER machine. So just this is all I have said, but because to make you understand, let us look at the video. And those who are looking for the first time, I understand that some of the terminology, technical terms, will be difficult for you to understand, but don't worry, it is just to make you understand that how complex and how fascinating this project is. Sorry, did I hear something? Okay, okay. Is it visible now? Okay. This was the condition in 2010, around 2009, 2010. Are you able to listen the audio of this video? No. Sorry, sound is not there. Okay, I was under impression that audio is also there. But anyway, I can discuss you. I mean, I will just describe. So these are different parts which are being assembled, and this is just animation. Different part how they are being assembled. If you see the outer one, it is cryostat, and this is the time when the project was finalized by 7 domestic agencies. After that, the site was being prepared for this experimental assembly or experimental setup. So this is according to design and contract award of different components, and this is how they are fabricated, and this is the site how it looks like at the moment. You see, these are different components, and you can see the massiveness of the component. This is the cryostat, which is provided by India. It is covered in a closed environment just to make it safe. So you can't see that, but in the video, in later part of the video, you can see those components as well. This is how the components are shipped to ITER site from 7 different domestic agencies. This is the one which is the lower cryostat, which is placed inside the building. You can see the depth of the building, and these are different parts coming from different domestic agencies. They are shipped to the ITER site. You can see this black zone. This is a heat exchanging unit. They are also provided by India. These are TF coil, which is provided by Russia, I guess. I'm not sure about this. So this is the animation that how assembly will be done and how the experiment will be performed. So these are different components. There are millions of components which are being assembled, and as I said before, everything will be done remotely. So you can see the remote operation of different component, how they are being assembled. This is animation as I said, but you can also see some of the real pictures of the site in this video. So these are magnetic coils which are being installed. And the most amazing thing is the tolerances, uh, despite of such a giant structure, very tight tolerances of about 2 to 3 millimeter are met in the assembly of these components. And you can imagine the size of the machine by looking at the man standing here. Of course, it's imaginary; it's not a real man, but for scaling, you can understand how giant it is. And this is the real site. This is the part of the vacuum vessel, and it is showing by animation that how it will be assembled in the machine. This is central solenoid, which is kept at the center. And this is cryostat top lid, which is closed for the commencement of the experiment. This is showing that how the machine are designed, which can lift a very heavy component of few thousand ton and even can rotate from horizontal to vertical. I wish you could hear this video, but of course this video is available online, so you will get the feel of it if you can, if you want to see that way. This is the original site of ITER, and this is actual images how the assembly is being taking place. So it says that once the assembly is being done, the experiment will start somewhere in 2025 towards the end, and that will be the experiment to establish the functioning of the component. So it is the first plasma which is planned to get generated in towards the December 2025. And this is the process which is shown that deuterium and tritium, how they fuse inside the vessel. So at very high temperature and extremely high magnetic field, the plasma of deuterium and tritium is there inside the vessel, and it gets fused and it releases a very large amount of energy with neutron and helium, which is the byproduct of the fusion. And this is again different parts of the vessel. It is called diverter. So this is the actual site from the outside, and there, if you see, the central one is for the tokamak, and there are other auxiliaries requirement which is shown side by. So I just stop sharing here and we'll come back to our slides again. Okay, so as I explained, these are some of the key features of ITER, and I'm unable to change the slide. Okay, and what India is contributing to ITER. So as I said, the outer jacket it's crushed, right? But there are several other components which are being fabricated, designed and fabricated by these nine packages of India, and then once they are established. See, for making those components, there are need of some prototyping, testing, and once it is established that okay, they are functioning well, they will be delivered to ITER site at France. So all this activity, most of them are being done in India, and these are some pictures from this nine package. It is difficult, I understand, to read out each and every text and to realize that how complex this component is. But just to make the thing short, these nine packages are essential things for the functioning of ITER, and it is they are being provided by India. So if you want to know further detail about this package, they are also available on our website, which you can visit. Now, these things to do all this work, I will just introduce our ITER India staff. So this photograph was taken long back, because after that I do not have any photograph of all the employees together, but this was taken maybe around 2010 or 11. But you can see very less amount of ladies in this picture. The status is of present female staff. It's about 13%. Uh, you can see most of them are here and some of them are in between. So isn't it surprising that despite of such a big project and lots of work, female staff is very less? But this is not surprising actually, because if we see the status of researchers in India, it is also the same. This is the report from TOI I have taken, and it says that only 14% of Indian researchers are women. Now, if you see that graduation part, most of the girls, yeah, if you see the girls are graduating more than the boys, then why that ratio becomes so less when it comes to the level of research or any scientific or technical post? Why it is so? So for that we have to find out the reason, and if all of you are willing, then we can have a small session where I need your video on, if it is okay with you. If not, then we can do it other way around. Maybe Miss Zuma can advise how should we proceed. Hello? No, we are going ahead. I can take the question right now or at the end of the talk. But I just wanted, if the participant be online, make their video on. It would be wonderful. Otherwise, we can go ahead with the next slide. Okay, fine. Okay, so the reason which we were talking about is the why this is a possible reason for gender gap in STEM fields. STEM means science, technology, engineering, and mathematics. So why there are less number of girls than the boys? So I have just putting few reasons, but there are a number of reasons I'm sure. But making the thing short, See, if we look at the first picture, limited opportunity based on financial condition. Now, suppose if a family consists of two kids, boy and a girl, and they can afford only education of one children, they will choose boy over the girl. Why? Because they think that okay, boy will grow up and bring money to the family. So that is the typical understanding of our Indian family, which need to be changed. But anyway, for the moment, what we can do is if the girl wants to go for further education, and if she's brilliant and she want to acquire higher study, then we can introduce them some kind of government initiative which they are doing for the higher study, for taking up research as a career, and then they can we can promote their education. Second picture is practical difficulty. I do not know where the picture has come from, but it is source is WhatsApp. But the essence of showing this picture is that if you see the path of woman is extremely complicated. If we consider this the race of a career or race of a research, it is not simple. This picture is not 100% sure, because if we see the boys, their path is also not as simple as it is shown. But uh, compared to that, female has little more responsibility towards the home and towards the society, which make it little complicated to go there them for a higher studies. So, but what is the solution? I believe that the girl should understand that you are born with a capability that you can handle both the things and still win the race. Okay, and the third is the most dangerous one is this stereotype thinking. Now, what is mean by that? Okay, I was discussing in the last slide to have a small session, but nevertheless, let us think here. When I say some name like a doctor, like a mathematician, like a scientist, like an engineer, who will come in front of your mind without any rational thinking, you will think that that person will be a boy. So that thinking, stereotype thinking is not that only boys are thinking like that way or girl are thinking like that way. We have brought up in this environment, and it is our subconscious thinking that certain job or certain profession belong to certain kind of gender, which is not correct. So that thinking we need to change, and based on that, girl need to go in research field more and more and start applying for similar kind of projects. And there are enormous amount of opportunity which are there, which we are going to discuss in next slides. So these are some of the government initiative which I could come across in very limited time, but you can go through the site and there are a number of uh, such initiative which aid a girl to go to take up her as a her career, and to take up higher studies in the field of science and technology. And these are some of the initiative mainly for women, and which are over and above with some general category schemes which where you can contest with a male counterpart as well. So the purpose of showing this is that those who really wants to take up uh, science or technology as a career, the financial conditions should not be stopping stone for that. Now, if we look at the opportunities at ITER, this is I'm talking about ITER at France, and this is the staff picture which was taken in 2017. So this was actually this is some report, and with that, if we see extract the number, the female staff is still promising about 22%, which is still better than what we have in India. Now, the trend, if we see statistics, so it started with 9% in 2015 and it reached to 22 in 2017, which is very promising. So it says that increasing trend depicts a potential opportunity for girl student to opt science as a career. they can opt for different kind of streams based on their choice, and then go for higher study, do some research, and then can apply in some project and contribute. So these are some of the multidisciplinary requirements at ITER. Um, this is not all. These are just a few which I am listing over and above the simulation and many other analytical assessment which are required for ITER kind of project. But these are some uh, branches which I have listed here where if you are interested, then you can opt for this study like nuclear physics. I'm just elaborating for the student if they belongs to lower grade. So nuclear physics, nuclear means the nucleus which is at the center of the atom, and the study related to that atom and its property of the nucleus which consists of neutron and proton. So that study is comes under nuclear physics. Then plasma physics. Plasma physics is all about ionized gas and their property. Fusion, I have already explained. Material science means material which we can see from naked eye, and if we look at it from the microscope, it it will be completely different. So the study about its structure, its performance, its characterization is all comes under material science. High energy ion and neutral beam. For ITER perspective, I have captured this image. This is used for heating plasma, but apart from that, there are several applications, and in India also we have several accelerator of similar kind to generate this kind of beam and for different applications. So that also you can opt for. Then radiation study. Radiation, when the fusion takes place or any kind of nuclear reaction take place, radiation comes out as a byproduct. How to deal with those radiation, how to extract them, how to utilize them, how to control them, how the radiation affect human being, how the radiation affect the material. All this study comes under these radiation studies. Then, if we talk about robotics and remote handling, as I said, that ITER is such a huge project. We cannot handle each and every nut and bolt with our own hand. So we need a remote handling tool. So that need design and developing such kind of tool is extremely huge work. So that is also another area of interest. Then engineering and technology. Here, engineering and technology, I have just put a image, but there are several branches of engineering based on your own interest. You can opt for it and go for the higher studies. Then comes the computation and data acquisition, because when the experiment goes on, you will get enormous amount of data, and you cannot compute it with a pen and paper. You have to have some data acquisition and computation system to work upon. So that is also another field which can be explored based on the interest, of course. So we are leading towards the end of the presentation. So for the opportunity at ITER India, IPR, and at ITER France. So if we look at IPR and ITER India, we have several students coming every year for summer training for their projects. Research proposals are being submitted. PhD and postdoc fellow comes every year. So uh, if you are interested in working in similar kind of subjects, you can apply and you can see the further details about the opportunity on our websites. And also at ITER, you can see the related projects and opportunity on this website. So with that, I'll just end by quoting Marie Curie. I'm sure you all will be aware of her. She's first lady who got Nobel twice for chemistry and physics. So what she says that you cannot hope to build a better world without improving the individual, and to that end, each of us must work for our own improvement. And believe me, our own improvement will pave the way for a better society, lead or establish a better society for tomorrow and the generation to come. So, with that, I thank you all for your kind attention.
Thank you very much for this nice talk. I'm very glad and at the same time very thankful to you that you addressed those issues for the women in science, and also you showed us the percentage. All we are trying to do in this International Women's Day program is to encourage the students, especially the girl students, so that in future we can make this ratio about 1:1, at least closer to that. We will look forward to that. Do you want to interact with the students now?
No, I guess I have explained. Actually, I want to make them realize that how they are. I mean, when I said about stereotype thinking, then I just wanted to make everyone realize that it is already there in our mind and how to extract it. That was the whole purpose of having that interaction. But now I have already explained, so it's okay.
Okay, then we can take up some questions.
Mhm.
Okay, there is one question. um, can plasma be an alternative to fossil fuels in near future?
Plasma, I won't say plasma, but fusion reactors uh, can be an alternative for fossil fuel. As I explained in that slide, because of the several limitation of fossil fuel, we are moving towards the fusion reactors.
Okay, another question is ITER safe in case of earthquake or flood, thus natural calamities?
Yeah, that's why it is called a safe reactor, because um, in this kind of reactor, chain reaction, which is expected in nuclear fission, is not expected. So, if you lower down the temperature of the machine, it will automatically stop the reaction. So, in case of earthquake or flood or kind of uh, phenomena like tsunami, which happened in past, and it create lot of problem in the nuclear reactors. So that part has already been taken care while designing this kind of reactors.
Okay, and generally, when people hear about those nuclear fusion or something, the first thing they think of about the radiation, because they get concerned about the radiation, and people actually are afraid of nuclear power and those power plants and
Mm-hmm.
those things. People don't
Right.
usually welcome it in a very open-minded way. I had one question. The slide 7, where you showed the technical details and the challenges as well. You mentioned about the length of the superconducting strand. So,
Mm-hmm.
what I'm not understanding is how are you maintaining such a big length? I mean, if it's just two times the Earth, then
Okay.
what's the total size? These things.
I got your point. So what happens in superconductors? If you see, the strands are wound like a coil. They are very tiny wires, and they are wound around that coil. Uh, so that is how, if you see the winding, it is very tight winding of such kind of strand. So if you measure the length, if you open it entirely, and if you measure the length, it will be like that. But in wound form, you won't see that length.
Okay, I have one question from that slide also, that how do you achieve that lowest and highest temperature? especially the highest one?
Highest one. Okay, so there are several subcomponents for heating of the plasma. So, out of which HNCD, neutral beam injector, I would say, neutral beam injector, electron cyclotron, ion cyclotron. These are some of the systems which are designed for heating the plasma. So, I'm not sure how much in detail we can go, but they provide about 50 megawatt of power to heat the plasma. So if we see a neutral beam injector, they inject the beam with very high current and megavolt of power, and they transfer their energy, kinetic energy, to the ions which are there inside the vessel, and that's how they heat. They transfer their energy and they heat the plasma. So these are the different mechanism by which heating is provided in ITER, EC, IC, NBI, as I said. And there are also another phenomena which I'm frankly I'm not aware about it. It's pallet injection, but I do not know the detail about it. But it is there. So by those means, by transferring those heat to the central part of the plasma which is existing in the vessel, the heat is being transferred.
Okay, I'm taking questions from the audience. There is one question. Is the basic working principle of this project kind of similar to the Large Hadron Collider?
No, I won't say that because in Hadron Collider, it is not working on the principle of fusion. This is purely fusion based.
Okay, few more questions. You also mentioned about different scopes. There is a question that is there any scope in India for PG students and what one should focus being at the verge of research?
What one should focus?
Being at the verge of research.
That I have already explained the different requirement of ITER and different disciplines where you need to focus upon. So based on your interest, after doing your PG, maybe you can go for research or you can do similar kind of work to make yourself, I mean, some expertise you can acquire, and after that you can apply for similar kind of projects. You can visit the site when some posts are coming or some projects are there. You can apply there as well. But it would be, I mean, I would advise that you acquire a minimum level of expertise in the area of your interest and then apply for the post or for further research.
We had one question from our Zoom participants, a very common one. Is nuclear a harmful gas for us?
Oh, I mean, nuclear, I guess the question is not properly traced. Nuclear phenomena, I would say nuclear having two phenomena, fusion or fission, also a decay, but right now we are concentrating on fission and fusion. So, yeah, when I'm talking about nuclear fusion, and it is not harmful as it is considered, I mean, in our case, and the way it is designed.
Okay, You mentioned that from India you are providing the cryogenics, that's your responsibility. And what are the other responsibilities from India?
Okay, so there are 9 different packages as I mentioned in that slide. You want me to go to that slide or I can just brief you about it? So there are 9 packages. Cryostat is the outer jacket, as I said. Then diagnostic neutral beam injector. That is another one which is for the detection of helium, which is a byproduct of nuclear fusion. So that injector is being designed and will be shipped to ITER. Then cryogenics and cryoplant, that is for cooling water is another package. Involved shield, which is used or designed for uh, suppressing the neutrons, which is placed inside the vacuum vessel. So that is another package, involved shield. So electron and cyclotron heating, as I said, they are also two different packages. They are providing part of the heating component for ITER. So, and of course, power supply. Power supply is another package who provides power supply for DNB, EC, and IC. So these are 9 different packages who are contributing in different aspects and different requirement of ITER.
I don't see any more questions. Okay. It was a very nice and very informative talk. I want to thank you again and all the participants as well for their showing their curiosity. And I'm very thankful for this lecture. It was very beautiful lecture for all of us, not only for women, for every Indian who are aspiring for walking in the frontiers of science. Uh,
You
okay.
very much. It was pleasure to interact with the student and you as well. And I once again thank Nehru Science Centre for giving me this opportunity. Thank you very much.